Hi there, and thank you for clicking on this practice set for simplifying rational expressions. Please give this video a quick thumbs up if you find it helpful. Subscribe to the channel for more math help. Drop a comment or question below, and check out the many other videos and lessons on the channel. As always, pause the video to work these problems on your own, and then come back to check your work. Okay, so I kept the practice set for this one at 5 problems because there is so much factoring. I kind of figured, well, if this were a factoring problem set, this would be 10 problems, and but it's not. But it is 10 factoring problems. And then the new material for, okay, what do you do with the factors once you have them is actually really short. So, all right, so let's take a look at this. We've got x squared plus 4x plus 4. So I'm going to be factoring these with the area model, and I'm not going to belabor the reasoning in the factoring. I'm just going to go through this as it would be done without a whole lot of explanation because this is not a factoring lesson. I'm going to refer you back to the refresher that I made that goes into more detail, and then I linked all the other lessons like from there if you need them. All right, so we are doing 1 times 4, which is 4, and then our factors of 4 are 1 times 4 and 2 times 2. And we are looking for something that adds up to the 4, which is going to be the 2 and 2. So this will be 2x and 2x. GCF between x squared and 2x is x. X times x is x squared. This is a 2. This is a 2. Checking 2 times 2 is 4, like in that. So that factors into x plus 2 and x plus 2. On the bottom, in the denominator, we have x squared and we have negative 2. 1 times negative 2 is negative 2. And we are looking for something that adds up to 1. Now, 2 only has factors 1 and 2. So if we want these to add up to a 1, we just have to be careful about where we put the negative signs. So if we want them to add up to 1, we're going to want negative 1 and positive 2. So negative 1x and 2x. So this will be x and x, 1 and 2. And so this becomes x minus 1 times x plus 2. The common factor. So remember, these are the factors, the things that are being multiplied. So x plus 2 and another x plus 2. And what they have in common is one of the x plus 2's. So if you are canceling them, make sure that you show that you are canceling the entire thing. The reason they cancel is because x plus 2 over x plus 2 is equal to 1. And whatever our expression is times 1 will just be our expression, which is x plus 2 over x minus 1. Ta-da! Looking good. Okay, now this next one we've got going on in the numerator. So actually, I'm going to do this. I'm going to start with the denominator. This is a problem-solving strategy that when I work with these through these with my own classes, I tell them basically play it smart. So if you've got multiple things that you need to factor, when you're doing this problem type, very, very often the factors are going to cancel. So if you can find the easiest thing to factor, there's a decent chance that you can get a hint about other factors. So let's take a look at this. X squared plus 3x. What I see there is that GCF, and I see a GCF of x. And then x times x would give me x squared, and x times 3 would give me 3x. So my denominator factors into x times x plus 3. And what that does is it gives me a hint. So I've got this GCF of x, and when I look at the numerator, I might be thrown by the fact that it is starting off with this x cubed. However, now that I see the denominator, and I see that the denominator does have a GCF of x, it might make me more likely to look at the numerator and say, oh, wait a minute, I have a GCF of x there also, and I do. So I'm going to go ahead and factor out one of those x's. Now that leaves me with the quadratic right there, which now I need to work on factoring that as its own thing. So setting up our area model, we've got x squared, we've got negative 15. We do 1 times negative 15 is negative 15. My options are 1 and 15 and 3 and 5. If I want that to come out to a negative 2, I need a positive 3 and a negative 5. So positive 3x, negative 5x, x 3, negative 5. So that ends up being x plus 3 and x minus 5. So my numerator is x times x plus 3 times x minus 5. And anything that is in common, I can cancel out. So x over x is 1. X plus 3 over x plus 3 is 1. And I am left with x minus 5. So, and that's a really good problem because if you watch the lesson, which I hope you did, I started off by talking about what does it mean to simplify. And I think when you look at this, look at the original expression and then look at our new one, and you can see, oh, yes, that is definitely simpler. Now, when you graph them, it's going to be some interesting stuff happening with the graphs, but that is for a future lesson. So, all right. Looking at this, so we've got, what do we have going on? We have no GCFs, so we are going to have to tackle both of these. I'm actually going to try to save myself some time here because these are similar problems. So I have a 6x squared and a negative 1, and here I have a 6x squared and a positive 1. So we multiply a times c, so 6 times negative 1, and I get a negative 6. Here I have 6 times 1, which gives me a positive 6. Now, why that's maybe useful is we end up with the same combinations, but we're looking for different things in the middle. So the first one needs to multiply to a negative 6 and add up to a negative 1. Well, to get this to add up to a negative 1, I can use a positive 2 and a negative 3, and just double checking 2 times negative 3 is indeed negative 6. So we are going to have 2x and negative 3x. And then here they need to add up to negative 5. Ooh, this is one of the tricky ones. So I have two possibilities. Positive 1 and negative 6 will add up to negative 5. Or negative 2 and negative 3 would also add up to negative 5. But here's where the multiplication part comes in. If I take these two, the 1 and the negative 6, and I multiply them, I'm going to get a negative 6. If I take these two and multiply them, negative 2 times negative 3, I will get the positive 6. So it's got to be that combination there. So this will be negative 2x and negative 3x. GCF, you know what? Let's save ourselves some time. I've got exactly the same setup here and here. The GCF between 6x squared and negative 3x, I actually usually try to avoid the negatives there, but it will be 3x. And then that makes this 2x on both of those. Now here, that's going to be a 1. 2x times 1 gives me 2x. Here, it's got to be a negative 1. And 3x times negative 1 gives me negative 3x in both of those spots. So we are going to have 3x plus 1 times 2x minus 1. And this is 3x minus 1 over 2x minus 1. My common factor is the 2x minus 1, leaving me with 3x plus 1 over 3x minus 1. And you cannot cancel all those 3x's, okay? If you were like, why can't I cancel them? Please go back, rewatch the video, okay? If you fast forwarded it, watched it on mute, I don't know, all the things people do. Go back and listen to the explanation. Please watch that. Okay. Oh, this is fun. So I don't see a GCF in that numerator. I'm kind of like hoping to see one, but that 5 is a prime number. So that's like throwing that off. This is a sum of cubes. So this is going to be a soap sandwich right here. Soap sandwich. So let's go ahead and do that one. So soap sandwich. Same, opposite, always positive. That'll be x, that'll be 4, because remember, you're cubing it. Okay, so 4 times 4 times 4. Don't put in 8. And then we're going to square it, and we're going to smush it together by multiplying. So x times 4. All right, now what that might do for me is, because I see the x plus 4, I am thinking that there is a good chance that one of those factors is going to be an x plus 4. And if I'm slick about this, maybe I can use that x plus 4 to help me. This is not a guarantee. Okay, it's not a guarantee that like anything is going to cancel. Anybody can give you a problem that doesn't have stuff that cancels in it, and that's completely fair game. But usually we're going to get some luck. So here's what I'm going to do. I am going to roll the dice, so to speak, and I am going to put an x plus 4 right there, and let's just see if it works. Okay, just going to see if it works. So let's see. So x times, this would make this 2x. 2x times x would give me 2x squared. That is not working, no. That is not working. All right, so let's not do that. I thought it was, but let's go ahead and check this. And then I'm going to go and check and make sure that, so this is negative 24. And I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, and we're looking for a positive 5, which we can get with a negative 3 and a positive 8. So I'm going to double check that. Negative 3, positive 8, negative 24, negative 3 times positive 5. All right, so let's go dump that in. And then that GCF is x, that's 2x. There's my 4. There's a negative 3. I cannot rewind the video in real time. So, but I really kind of want to. Feel free to leave a comment. All right, common factor is the x plus 4, and that leaves us with 2x minus 3 over x squared minus 4x plus 6. All I can think is, like, did I just panic because I'm recording and think like just like had a brain freeze, or did I write something wrong? But there's the solution. So not really solution, the answer. There's the answer to this problem. There's your simplified version. Ta-da. Okay, I'll probably cringe over that later, but let's just go do the last one. What is this mess? Okay, well, this looks like fun. All right, first thing that I'm going to notice is I have a ton of even numbers going on. So that right off the bat, I'm thinking good news is we can factor some stuff. So we can at least factor 2 out. So that'll give me x squared minus 2x minus 35. Not super thrilled with the 35, but I know that the answer is going to be 7 and 3 because 7 and 5, because 7 times 5 is 35, and they're 2 apart. So I know I can get the negative 2 from them. So, I feel okay about that. Let's go and put that down in some scratch work. So we got like the 1 times the negative 35. So we're looking at factors of 35. That's 1 times 35. And then 5 times 7. I think that's all we've got. There's my combination for the 2, positive 5x, negative 7x. We'll do that. So we get x, 5. So there we go. But don't forget the 2. So we have 2 times x plus 5 and x minus 7. Now, this one down here also has a GCF of 2. Kind of hoping it would be a 4, but it's not. It's a 2. So we'll do the same thing there. It's not going to come out quite as nice, but 2x squared plus 3x plus 5, and at least they're not enormous numbers. So, okay, so we set up our area model. We've got 2x squared, we have a 5, and then we have to do 2 times 5 is 10, and so we're going to be working with 1 times 10 and 2 times 5. We want it to come out to a 3, which it can't, which means that I have a sign error. I'm going to pause this for a second. Okay, so yep, I verified that. I'm looking at when I wrote this problem, and I wrote it and basically multiplied a binomial. I made an error, a sign error when I multiplied the binomial, and so it made it into the final cut. So here's the correct answer. So you go through all of this and it does not factor. And so you get this, okay, and the 2's will cancel, and that is as far as you can go. And so the final answer would be x plus 5, x minus 7 over 2x squared plus 3x plus 5. Bat 1,000 today on the problem set. Maybe not, but maybe at some point this is one of those ones that, you know, if a ton of people flood the comments with like, hey, you moron, you don't know math, I'll feel bad and I'll like, I've got to go re-record it. Or you can think of it as this is like an authentic real person, like ain't no AI doing this video, that like sometimes has little what we call brain farts when I am doing stuff. So if that's what you got for the answer, then bravo. You were not losing your mind. Although the person making this video might have thought that she was. Okay, so please like and subscribe if you found this helpful, or if you just get entertained by a math teacher. I don't think I didn't face plant, but we kind of tripped in this one. Drop a comment or question to engage, and please check out the many other math resources that are on the channel. I promise I don't trip on all of them. So the algorithm, because we all love the algorithm, thinks that you will like the one that you see below. Please check it out, and I hope to see you in a future video.